Namaskar. I'm Harpreet Kaur and I welcome you all to our live and interactive session on virtual labs. You are watching us right now on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT official. Today we have taken the topic demonstration of simulation on volume of a sphere. In this session of virtual lab, this session is specifically meant for the students of class 10 and the subject is of course mathematics. I'm sure when you say sphere, it automatically comes to our mind that it's a mathematics arena. Now, when I was a kid, I used to cram the formulas because I never knew that how I can actually derive them. There were no virtual labs at that time, but today we have this facility through which we can learn about many abstract concepts. They are visually available and we need not to cram or mug the things up anymore. So what you can do to understand it even better, we will be performing the simulation for you and you can reach out to us through various mediums. Our phone number is 8800440559. We also have a specific email ID for you, that is diksha.training@ciet.nic.in, and you can always send us your questions, suggestions and feedback on our YouTube handle NCERT official. Now, before I introduce you all to my guest for the session, it's important to tell you about virtual labs. There are so many of you out there who have joined us today for the first time and you must know what virtual labs are all about. So, virtual labs, it's a kind of an online platform or an application tool where you can perform simulations in a virtually simulated environment in a controlled environment. Now, we are not saying that virtual labs are a replacement of real physical laboratories, but they help you prepare before you actually go into the laboratories and perform the experiments over there. So you can perform the simulations or experiments at your own time, pace, space and convenience. Also you can repeat them n number of times. It's very cost effective. All you need is a stable Wi-Fi connection and an IoT device and you're good to go. Now we have heard of performing simulations of sciences, but when it comes to mathematics, my goodness, is it challenging or easy? I don't know. So let's get the answers from my experts. Please join me in welcoming my guest for the session, Miss Shivani Sharma, Academic Consultant from CIET NCERT. Ma'am, namaskar and very warm welcome to you.
Namaste, thank you for having me.
Well, pleasure is all ours and I have already told them a bit about virtual labs and we all know that there are different kind of simulations across various disciplines that we can perform on virtual labs. But before we get into the nitty-gritties of the topic today, I want to understand how we can learn maths effectively from virtual labs, because math is generally considered a very difficult subject. We are unable to relate the concepts of mathematics to the real life applications. So how do you think virtual labs here are playing an important role?
Yeah, sure. So as you know that many people are afraid of mathematics, but maths is actually a simple subject, and the beauty of subject is this: once you visualize the concept, you will remember it forever. So you can consider virtual lab as like a playground of mathematics where you can play with the numbers, shapes and find the result in the form of geometry.
Lovely. So you're talking about gamification of concepts here, which is one of the objectives of digital education scenario. Now, another thing I want to understand, today we'll be talking about volume of a sphere. I remember, just cramming the formula, learning it by heart, and now I don't even remember. But I want to understand what exactly is the relevance of the topic today. What are we going to learn?
Yes. So today I am going to demonstrate one of the experiment of the virtual lab, and that is based on the concept of the volume.
Okay.
So instead of just memorizing the formula, here we can see by the experiment, understand by the experiment that how the formula is derived and why it is equals to 4/3 pi r cube.
Lovely. We are looking forward to it. So now let's start with the demonstrations, and before that, one simple question as always: where can we find these virtual labs and do we need to sign up?
Yes, it's free of cost and you have to sign up for the one time.
Okay.
So for the
where we can find it?
So you have to type www.diksha. You have to type www.diksha.gov.in.
Okay.
Otherwise, you can simply write Diksha on the platform and you just click it here.
Okay.
This is the home page of the Diksha.
Right.
Right. So when you scroll down, there are some focus areas of Diksha, and one of the focus area is virtual lab. So click here. You will find the tab of virtual lab. Just click on the explore button. You will land on the home page of virtual lab.
Okay.
So you can you can read what is virtual labs.
Complete write-up is there on it. Okay.
Right. And when you scroll down, you will see that the content is available from class 6 to class 12th. Now today's our topic is based on class 10th.
Yes.
So we will click on Explore tab, and here we see that the content is available in both Hindi medium and English medium.
Okay.
So we have to click it here, English medium, and the subject, we have to choose the subject which is mathematics.
Great.
So we will land on this kind of page. So here I have already logged in, but you can register yourself if you are first time user, otherwise you have to log in with the credentials.
And I can use my Gmail ID for the login, and
Yes.
anybody can log in. This
Anybody
training
can
session is
log in.
open for all. Okay.
Yeah. And when you scroll down, so for today's topic is based on the sphere of a volume, volume of the sphere.
Yeah.
So we scroll down, and there is one tab, more experiment. If you click it here, you will see the topic which is volume of the sphere.
So we have this table of contents here, and from this we can pick up anything if you
Yes.
like. Okay.
So for today's purpose, I am clicking on the simulation button.
Okay. It's getting loaded.
It's getting loaded and the content is available. Now we have to click on the start tab.
And there were learning objectives also, and it's written here again.
Yeah.
Okay.
So first, whenever we do anything, we have to go from the theory part. What is the theory behind it? So we will click it here, and for I am giving full screen.
When you say theory, you mean to say I need to understand what I'm going to perform, what this concept is all about, right?
Right.
And before performing this simulation, we have these learning objectives, that why are we performing these simulations at the first place?
Yes.
Okay.
So the theory is first write the objective to give a suggestive demonstration of for the formula of the volume of a sphere in terms of radius. So what we are going to do here we are derive the formula of sphere with the help of cylinder.
Okay.
So first there is some prerequisite knowledge section in which we should know what is cylinder and what is the volume of cylinder and the basic definition of the sphere. So please note it that the volume of a cylinder is pi r square h, and we are using it to derive the formula of volume.
Now that's interesting. We want to find the volume of a sphere, but we are starting with the cylinder.
Yes, as we can see that the sphere is a 3D figure which is made up all the points in the space which lies at a constant distance called a radius, and from a fixed point called a radius of the center of the sphere.
Okay.
Now what is radius? The radius of a sphere is a line segment between the center and the point on the circle of a circle or sphere.
Okay.
So this is radius, and the double of the radius is the diameter, and it is passing through the center. Now the volume of the sphere is 4/3 pi r cube. Now we will move on the second section, that is procedure.
Right. And before you move on to procedure, when you say sphere, of course Earth comes to my mind.
Right.
And can we say that the equator line is kind of a diameter of Earth?
Right.
Okay.
So now it's a picturized version of the simulation. So you can explore what is where you have to click, what you have to do for the experiment. You can go through it.
So we have this visual representation of the procedure.
Right. And the next part is the animation part.
For those who are interested in video.
Those who are interested
Audio,
in the
video
video,
material.
and also you can explore where exactly you have to click for the experiment, for the simulation. So this way you can see what steps
And
you
this
need
box
to follow.
is all about the instructions?
This is all about the instructions,
Okay.
where you have to click, where you have to
Okay.
write. And the next part is simulation. For the simulation part, this type of page has come. You have to click on the start button, then click it here and read the instructions carefully.
Okay.
After reading the instructions, you have to click on OK button. Now there are some specific things here. The instruction part is given, so you have to read all the instruction before performing the simulation. The first instruction is click on the respectively checkboxes to generate a sphere and 2 cylinder. So we have to scroll down, and there are 2 checkboxes. We have to click it here and here, and we can see that the sphere is generated and also 2 cylinder is also generated.
Right.
Now what is the observation here? A sphere of a diameter 2r has been drawn. So this is a sphere and the diameter is 2r. Same way the cylinder of height 2r. So this is the height and it is 2r. Now the instruction is click on the next button to proceed. So we will click on the next button. Now what we are seeing that it's an empty sphere. and the instruction is click on the sphere to fill it with the sand. So we have to click it here. Now we are saying that sand has been now filled with the entire sphere. Again we have to click it, and we are seeing that the sphere starts rotating and transferring the sand into the right cylinder. Now again we have to do the same procedure, click on the sphere to fill it with the sand, and again click on this. Now it's fully filled, again click here, and what we are seeing that it is now cylinder is fully filled now.
Yes.
And sphere is half filled. So we have to fill the left cylinder.
Okay.
For this we have to click it here, and now we are seeing that the half filled sphere is now shifted to the left cylinder.
Right.
Again half filled sphere is positioned about the left cylinder. Again do the same procedure. Click it here. The sphere start pouring its sand into the left cylinder.
Okay.
Again we have to fill it. To click on the sphere to refill it.
We have to fill it till the sand comes to the brim of the cylinder, right?
Right. So the sphere is now completed with the sand. Again we have to click it here. As the sphere starts rotating and sands begin to flow in the left cylinder. Now what is the observation here? So we have to after 3 pouring from a sphere, both the right and left cylinder are now completely filled with the sand.
That's right.
So this is how this experiment is complete, and there are some observations which we can see. Verification is there.
Okay.
So what is the diameter of the sphere? So this is the sphere, and what is diameter? 2r. So what is the diameter of each cylinder? Same diameter, 2r diameter.
Okay.
So what is the height of the cylinder? You can see the height is 2r. We are doing nothing, we are just observing. So I am putting 2r as a 2r. So it shows that it is correct.
Okay.
Now the next point is, we observed that it took how many sphere to fill the sand into the sphere to completely fill both cylinders. So it took 3.
Yeah.
But what happened if we do 2? So it shows that it's a incorrect option.
Okay.
So we have to do only 3, and then it's a correct option. Now what is the observation here? 3 into volume of sphere is equals to 2 into volume of cylinder, as we just saw. So we have to write it 2. So there are some calculation. We have to find the volume of sphere. So we will do calculation for the volume of sphere. So 2 into pi r square h. So pi r square h is the volume of cylinder. So we write it pi r square h. Now what is h? As we show in the figure that it's 2r. So we write it as a 2r. Now 3 comes down and it will become 4 by 3 pi r cube, and that's way we can derive the formula.
Wow, it's that easy.
Yeah.
And it has been made so easy because now we have a simulation in front of us and we can actually visualize the thing.
And the best part is there are restart button. If you are not satisfied with your experiment, then you can again restart it, and
or if I haven't got it in the first time, I can always restart it and practice it a number of times.
Yes.
Okay.
so the last part is the assessment part.
So is this all about the simulation here?
Yes.
Okay. So once the simulation is done, I want to test myself, right?
Right.
Because we always say that no teaching learning process is complete without self-assessment, self-evaluation. Now there are no teachers involved here. You're doing it on your own.
Right.
So in self-evaluation, what happens? We get some questions and we need to answer.
As we know that the first question is the radius of a sphere is r, then its volume will be. So we just know what is the volume of the sphere is 4 by 3 pi r cube, 4 pi r cube, 2 by 3 pi r cube, 4 pi r square by 3. So we just got to know that the volume of sphere is A. So we have to click on A and then submit button. So that's the correct answer.
Now before you move ahead, I can see that there are 10 questions and all, and we are also getting scores, and we are also getting the timeline to perform the solutions. I mean, so basically you can check your speed also. That's wonderful.
Yes.
Yeah.
And after completing the first question, I have to click on the next button. So now the second question has come. So here find the volume of the sphere when the radius is 3 centimeter. So what we are going to do, just write the formula of the volume.
And you can watch ma'am perform the
So just write the formula of volume, that is 4 by 3 pi r cube, right? And what is r? R is given as 3 centimeter. So we have to put the value of r in the formula.
Yeah.
So write the volume V
We'll
equals to
substitute
4
it.
by 3
Yeah.
into pi into 3 centimeter into 3 centimeter
Into 3
into
centimeter.
3 centimeter.
It's a cube.
Right.
And for
So-
pi, we will write 22 by 7.
Right.
Okay.
So
4
here
by-
we calculate the value and we will get 36 pi centimeter cube.
Okay.
Now the correct option is option D.
So we are not putting the value of pi here.
Right.
Okay.
Because the answer is in the pi form, that's why we are not
Okay,
putting.
great.
And the next question, again we are going on the next question.
Hmm.
Now it's a, here you have to put the value pi as it is given as 3.14.
Right.
So again put the formula of volume, write the formula
And
of
you
volume.
can simultaneously solve the thing in the rough sheet also, like
Right.
ma'am is doing.
Right. The formula is 4 by 3 pi r cube
Hmm.
and you have to put the value pi as 3.14 and r is 7 centimeter. So
Okay.
write the volume as 4 by 3, pi is as 3.14 and centimeter 7 centimeter, 7 centimeter and 7 centimeter.
Yeah, because you either write 22 by 7 or you write 3.14.
Right. So we will, when we calculate this, the value of the value will come as this figure and then we have to click on the option B, which is aligned with option B. So we have to click on option B, then click on the submit button and that's how the answer
And
is
wow,
correct.
your answer is correct. And it's important to understand this concept very nicely because it's an important question in class 10th examinations, right?
Right. So we have to click on the next step.
Yeah. Let's
Again,
go for the next.
this is the question to experimentally derive the formula of a sphere, volume of a sphere. It is often compared with solid, as you just saw that we have compared our figure with the cylinder. So we have to click on the cylinder.
Okay.
Now what happened if we click on the cube?
Okay, let's see.
Let's see. When we click on the submit button, it shows that it is incorrect and the explanation is also given.
Why it's incorrect?
Yeah.
Okay.
So we have to close it, correct our answer and then submit it.
Great.
So this is the correct answer. Now we will move on.
So you can't make mistakes in virtual labs even if you're willing to,
Right.
because you get help on each step.
Right.
Okay.
So the next question is find the volume of a sphere.
Yeah.
And now in this question the volume of a sphere is given, that is 36 pi.
Okay.
36 pi cube units, like centimeter cube, inch cube, anything it can be. Now what is the radius in terms of unit? So in that kind of questions we have to write formula V as 4 by 36 pi, write the formula for the volume which is 4 by 3 pi r cube and that is equals to 36 pi. Now calculate for r cube, that is equals to 36 into 3 upon 4 and that is equals to 27. That's so r will be 3. So the answer will be 3 unit.
But again,
Click on the
it's in units, so you have
Right.
to put the unit as
unit
well.
also. Right. So we
Right.
have to put the unit also.
Yeah.
Right.
Great. Okay.
So this way we can move forward for the next question.
Yes.
Now this question is very important. The radius of a sphere is halved. Then how does the volume changes? So first we have to write our original volume and then we are doing the radius half. So what is our original volume? This is our original volume 4 by 3 pi r cube when the radius is r. Now it is given that the radius is halved. So r is by r by 2. Then what happened to the volume? So we replace r by r by 2. V equals to 4 by 3 pi r by 2 cube and that is equals to 4 by 3 into pi into r cube by 8. 1 by 8 we can write it as 1 by 8 4 by 3 pi r cube and this is our 1/8 of the original 1/8 of the original volume. So the option C, it is aligned with the option C, which
Okay.
is it becomes 1/8 of the original volume. So we can click here,
Let's see.
submit button, and that's how
Okay,
the answer is
correct.
correct.
Okay.
Right.
Let's
So
move forward.
next question, the volume of a sphere is inversely proportional to. So we are writing the formula of volume and we can see that the volume of a sphere is inversely proportional to not its diameter, it's not its radius, it's not about the circumference, it's about the cube of the radius. So the option is cube of the radius, that's why the option D is correct, which is none of these.
Okay.
So we have to click on the submit tab and the answer is correct. Now we will move forward for the next question.
Okay.
So for this question,
Yes, you read the question, ma'am, for the viewers, please.
yeah, so the question is, what is the ratio of the volume of a sphere to the volume of a cylinder with same height and same radius?
Again, it's a 1 mark question, and like all the questions, you can definitely solve it.
Right. So for this question, you should know what is the volume of a cylinder also.
Okay.
So first, I have volume of sphere, which is 4 by 3 pi r cube, and volume of cylinder, which is pi r square h.
Okay.
As we can see in the diagram that the h is 2r. So what we are going to do, 4 by 3 pi r cube upon, find the ratio of 4 by 3 pi r cube and pi r square into 2h. So 4 by 3 pi r cube upon 2 pi r cube. So h is 2r, so we are putting h as 2r. Now we can compare both the quantities, find the value in the ratio, and then we will see that it will become as 2 by 2 ratio 3 or 2 by 3. So the answer will be C. So that's how we have to choose the option C and
Okay.
click on the submit tab. Now that answer is correct.
Yes.
We can move forward.
We can move on to the next question.
Right. So similar way we can put the value of the radius at 6 inches and find the value. So the answer will come as V equals to 4 by 3 pi r cube, and r is 6 inches. So what is the volume? 4 by 3 pi 6 into 6 into 6 or 6 cube. So that's how we calculate this, and we'll get answer as 288 pi. Write the answer in the form of pi because all the options are in the pi form, and inch cube. So that's how our option C is correct. You have to click on C, and that's how we can do the experiment. And you can again, this is the question is, what happened to the volume if the sphere of radius is triplet?
Right.
And you can see that the r cube is there, so it will become 27 r cube. So the original volume becomes 27 times larger, and that's how you can submit our answer and finish your assignment.
Okay.
And at last you can check your performance also.
Right. And how much you've scored, ma'am?
10 out of 10.
Oh, great. So means you actually understood the concept well, and you not only understood the concept well for us, but you also made us understand the concept well. It's very easy. You perform the simulations, you perform the self-assessment, and you're good to go. So now we do not have enough time left in the session, but I must say that it was really interactive. And before I finally close, would you like to share some closing remarks?
Right, because mathematics is subject of practice, you don't need to memorize anything. It's a learning by doing process. As much as you practice yourself, as much as you learn. So virtual lab is also based on this kind of concept. It enhances the learning by doing method.
Well, that's absolutely fantastic, and I must thank you for this very delightful journey. Thank you so much for your time and contribution to the session. So my dear viewers, it was our session on virtual lab. So we talked about demonstration of simulation on volume of a sphere. But tomorrow we will bring up another interesting topic for you, and we will have a demonstration of simulation on show that hydrogen gas is evolved by the action of acids on some metals. So please stay tuned for the same, and do get ready with your questions. You can take the pre-lab session yourself, and then you can perform the simulation here and be ready for the real physical laboratory. So with this, I'm wrapping up the session here, but before I finally leave the studio, it's time for me to share some quick informations. Let's talk about the textbooks first, which are available for grade 4 and 7 on Amazon, Flipkart and NCERT website. You can grab your copies from there and simultaneously take a quick look at what's coming ahead. Here is the program schedule. So we are through with our session on virtual labs, and in a short while from now you can watch another session of ours, and that will be on teaching learning interventions for inclusive classrooms. Of course, we are going to bring you a very important topic that will be Beyond Eyes, National Association of Blind. Well, that's the organization that will be participating. 2 p.m. is the time for a session of Urdu, followed by a session of Hindi at 2:30. 3 p.m. is the time for a session of the subject The World Around Us, where we will be talking about nature trail, followed by a session of English at 3:30. Be smart, be safe would be the topic. 4 to 5 p.m. is the time for our online training program, where we will be talking about universal design of learning, and we will end the day with our session Sahyog. The topic will be handling rejection and failure during adolescence. Well, that's absolutely important, because rejection is only redirection. And now I will join you very soon, but you stay tuned for more programs on our various handles. This is me, Harpreet Kaur, taking leave of you. Namaskar.